Ryan is a forest ecologist, and his time is split between the Washington and Idaho chapters. He's working on dry forests throughout northern Idaho and eastern Washington. And Ryan will be talking about assessing forest conservation needs for whole system conservation.
So Brad, want to thank Brad so much for the opportunity to talk with everybody, to show some of the work that we're doing in Washington, Idaho, and Oregon. My outline here is pretty simple. First, going to just set the context for our TNC conservation work within western forests, and then just dive into and show how we've been putting the Landfire data, tools, models, and concepts to work. So as I'm sure that most of you are probably well aware, historically fire was a very important part of many forests across North America, particularly within the west and the southeast. And unfortunately, when we look at the west, there's a real common storyline for these historically fire-dependent forests. We see that there's a history of wildfire suppression, harvesting, and grazing throughout the 20th century has left many of these forests susceptible to uncharacteristic disturbances such as mega fires that we hear about in the news and catastrophic insect and disease outbreaks. These disturbances threaten not only the tremendous biological diversity that are supported by these forests, but the benefits, clean air, water, fiber production, that millions of people depend upon. So while the challenges that these forests face seem daunting, we have hope. And one of the major strategies that the Conservancy is using is to achieve conservation through active ecological restoration, using tools such as prescribed fire, mechanical thinning, and harvest. And in fact, ecological restoration has really become the dominant paradigm for management of federal forests across the western U.S. It also produces a really exciting synergy between conservation and the local communities which are economically dependent upon the forest industry. So in large part, we at the Conservancy were seeking to achieve our conservation and restoration goals on public lands by working with collaborative groups, where we bring together loggers and sportsmen and ATV riders and snowmobiles, environmentalists, local governments, tribes, and many others. Bring these big diverse groups together to try and solve land management conflicts. And one of the really important roles that TNC often plays in these collaborative groups is to help bring people together and develop what I like to call a shared vision for forest management. And in developing these shared visions, one of the most daunting questions that both the Conservancy and the forest collaborators face when looking across millions of acres is determining just where, how much, and what kinds of forest management we want and we need that we can all agree upon. And this is really a critical question, because how do we know if the pace and the scale of our restoration is making a difference out on these forested landscapes? So our work to develop an approach for assessing forest restoration needs has initially focused on the interior forests of eastern Washington, here in the blue, and of the Clearwater Basin in northern Idaho. But at the very same time, there's folks like Chris Zanger in Oregon, the Landfire team, have been doing very similar work. So now we're building multi-state partnerships with TNC in Washington and Oregon and Idaho, along with U.S. Forest Service and Landfire, to implement what I like to call these restoration needs analyses across the entirety of these three states. Okay. So there are two primary tasks that we've been undertaking in these analyses. The first of which is to compare today's forest to the natural reference conditions. And Randy did a great job of talking about what are these natural reference conditions. They don't necessarily represent the desired future condition in a technical sense. That has to incorporate all kinds of other social, economic, and other ecological considerations. But by using a natural reference condition, it gives us a really powerful starting point and something to which we can compare where we are at today. And then again, our second step is to determine what actions could move today's forests toward the natural reference conditions. In starting our work in Washington and in Idaho, it became quickly evident to me 2 years ago that Landfire was just an invaluable source for both continuous and consistent data on both current and natural reference conditions. And in addition, folks like Randy and Corey and Jim are incredibly nice and helpful people as well. So that makes it really easy to work with the Landfire product. So again, as Randy described, at the heart of Landfire is a classification of landscapes into different biophysical settings, or BPSs. And for each of these BPSs, we can characterize them as, by their historic relationship with fire. We talk about low severity fire regime forests, mixed severity fire regime forests, or high severity fire regime forests. Randy also introduced the idea that we can describe both natural reference condition and current condition for these BPSs in terms of successional classes. And then our analyses are based upon a comparison of a relative abundance of these different successional classes today versus the reference condition. Okay. So the first stop in our analyses and our processes has been to look at vegetation departure. Again, what the concept Randy introduced and that Louis is really going to drill into in the next talk. At the most basic level, again, departure is a measure of how different today's forests are from the reference condition. On a 0 to 100 scale, 0% means today's forests are looking exactly like the reference, 100% means they're completely different. So using the basic departure analysis, we see that across the 12.4 million acres of forests in eastern Washington, over 73% have a structure and composition that is moderately to severely departed from the natural reference condition. And that these levels of departure are not consistent across the state. In eastern Washington, we see at their highest in and around the Methow Valley within the north central Cascades. We see that in the Clearwater Basin in northern Idaho, there it is forests that have a historic mixed severity fire regime are the most common and most consistently departed forest types. And these mixed severity forests constitute over 70% of the national forest lands here in the Clearwater. And so we've been finding that departure is an incredibly interesting way to summarize our landscapes, and that the collaborative groups we work with have really adopted the departure maps and departure summaries. But departure by itself leaves the question of why a particular forest is out of whack compared to the reference. Departure could be the result of widespread clear cutting within the landscape, or because of wildfire suppression. And it's really important to distinguish between these two, because the need for active ecological restoration is clearly very different in the context of clear cutting versus, wildfire suppressed landscapes. Comparing the relative abundance of the successional classes today versus the reference can give us some indication of what's wrong. For instance, these graphs are from eastern Washington, and we see that within the low severity forests, our lower severity forests today are dramatically short of late development open canopy forests, and we're way overabundant in closed canopy forests. This is exactly the pattern that we would expect to see from a history of wildfire suppression. But surprisingly, this isn't the same pattern that we see within the mixed severity forests of eastern Washington. However, this still doesn't tell us how many acres within these landscapes are in need of active or passive restoration. And that is the next step of our assessment. Okay. So to help sort of provide some terminology here, when I say active restoration, I'm talking about actions that result in a reduction of canopy cover and or tree density. And at the scale, across millions of acres working with Landfire data, this term active restoration can be accomplished through either fire or mechanical treatment. Certainly on the ground, there are very real ecological differences between, the mechanical thinning with chainsaws and equipment versus the outcomes for wildfire. But when we scale up to this very broad level, we're lumping those together. contrast, passive restoration is simply allowing the forest stand to grow into a later development successional class. Okay, so the idea here is that our forests in the West are out of whack, or when our forests are out of whack, it's because we have acres that are in the wrong successional class, quote unquote wrong. And that we can define what types of actions would move acres from any one successional class to another if that is what is needed to restore or rebalance today's forest. So this slide is kind of a mess here. I call this my spaghetti diagram. But we have the 5 typical Landfire successional classes. And then these arrows define which of the transitions between successional classes would be achieved through active restoration. Those are the red arrows. Which transition between successional classes would be passive restoration, the blue arrows, and or which transitions would be a combination of both active and passive restoration. Those would be the purple arrows. Another perhaps simpler way to look at these transitions is within a matrix, again, which highlights which transitions between successional classes are active restoration, red, which are passive restoration, the blue, and which are a combination of both. So in our restoration needs analysis, we've developed a process for efficiently assessing these transitions for large numbers of DPSs and landscapes through a stepwise process using what I call rules tables. So the slide shows an example of one of these rules tables for a typical low-severity fire regime forested biophysical setting. So the way this analysis works, starting on the first row here, we take a DPS within a landscape, and we determine whether there is an excess of acres compared to reference in the donating S-class. Here in this example, it's mid-development closed canopy, and whether there is a deficit of acres within the receiving S-class. Here would be mid-development open canopy. If there is a excess in the deficit, or an excess in the donating, and a deficit in the receiving, we quote-unquote move acres from the donating to the receiving, and we tally those acres up as this action. This would be either thinning from below or a low-severity fire. So that would be an active restoration. So then after we've hypothetically moved those acres, we move down to the next row and assess again the same process, whether there is an excess of acres within the donating S-class, whether there's a deficit of acres within the receiving S-class. If there is, we move acres from the donating to the receiving and tally those acres up by this category, by the action category. If we hit a row where there is not an excess in donating, deficit in receiving, then we just skip that step and move on to the next row. So when you roll up those types of summaries from many DPSs across many landscapes, we're able to provide summaries such as, within the Clearwater Basin, there are 1.3 million acres of forest in need of active restoration compared today to the natural reference. And that active restoration needs are highest within the South Fork Clearwater subbasin, where we find over 35% of forests are in need of active restoration. Also within the Clearwater Basin, there are over 300,000 acres within the eroded front country of the Nez Perce Clearwater National Forest in need of active restoration. And as you might expect, these numbers the collaborative group gets really excited about. But this method of the active restoration analysis also provides us with more specific information on the various types of restoration needed. For example, here within the Clearwater Basin, in the mixed severity forests, the restoration needs are not, these mixed severity forests are not typically in need of the traditional thinning from below types of treatments that we think of from, say, example, ponderosa pine forest in the Southwest. But it's actually other types of more complex thinning. As I mentioned earlier, we started focusing on the Clearwater, somewhat smaller landscapes, 6 million acres of the Clearwater in northern Idaho, eastern Washington. But now through these multi-state partnerships, we're rolling these same ideas out across multiple states. And here we have draft output from our Washington and Oregon restoration needs analysis. Here showing active restoration needs in the red, passive restoration needs in the blue. We're doing this in close partnership with Chris Anger and others in the Oregon chapter and the regional offices of the Forest Service. So today, I'm proud to say I think we've had a number of successes with this analysis approach. The Clearwater Basin Collaborative in northern Idaho recently, signed a comprehensive agreement and work plan that received, widespread local and actually even national press. And at the centerpiece of that agreement was our Landfire-based landscape assessment that TNC was able to provide to the collaborative. Within the DePosh Collaborative in eastern Washington, we're using the same approach as a foundation for assessing an economic strategy for how can we fund and afford to complete needed restoration in a landscape where forest industry and forest mills are absent. And working with the Forest Service in Region 6, Washington and Oregon, they're using these approaches to set, again, region-wide context and prioritizing their resources and approaches. So a number of the next steps, as Randy talked about, we found that it's really important to take local data wherever possible. And so right now, especially in the Washington and Oregon analysis, we're taking these landfire concepts that we've developed, but we're applying it with other sources of both current condition data and even some other data on reference condition. Corey Blankenship with Landfire has been a huge help on that. And again, we keep trying to scale this out to larger and larger geographic scopes. And as we're getting these restoration needs summaries, trying to link that to other social and economic outcomes. How do we compare and balance economic and ecological outcomes? How much funding is it going to take to meet these restoration needs? And then finally, I forgot to put a link on here, but we're also, the final piece of next steps is how do we better incorporate ideas of climate change and climate variability into our reference conditions. So the work is far from done, but it's really exciting so far. Many people to thank on this work. The entire Landfire team, Corey, Randy, and Jim, have just been tremendously helpful. Again, Chris Anger and the team in Oregon have been hugely important partners for us. Leanne and Darren in Washington, Nathan and Bob in Idaho have been integral pieces of this work, along with the Clearwater Basin Collaborative and the regional office of the Forest Service in Oregon and Washington. So with that, love to answer any questions. There's my email address. Feel free to shoot me a note later on if you'd like. And a couple of different websites where we have various reports from this work uploaded. So with that, I'd love to launch into conversation if there's any questions.
So I will throw out a starting question. How much did you have to come up with these approaches yourself, and how much were you able to adopt approaches that were developed for use in other Conservancy OUs or other organizations?
Yeah, so the way this worked, the first stage of this work in both Washington and Idaho was the ecological, or was the vegetation departure, in which we took straight up that process from the Landfire program, and we filtered the data somewhat to focus in on the forests that we were concerned with, but that was really fairly standardized. And then building from there, the second piece, the restoration needs, is something that Chris and myself and others have really, in a sense, developed from scratch, trying to take the Landfire concepts but move it a step further.
So following up on that, how much of this could be picked up and run with by other OUs or organizations?
So right now we have have most of this built up as within Python scripts, and the methods are written out. It's I have to say it's not an easy plug and play, but if there are other scientists or landscapes that are interested in taking these approaches, I would love to talk and help people out. So it's a little bit of investment, but doable.
I have a question for Ryan. If no one's else going to ask, this is Louis.
Hey, Louis.
So you were showing a table where you have fin and low fire afterwards as a prescription for acres that are departed.
Yep.
Now you guys put acres on a map, but do you have plans for, let's say you identify an area for restoration, and then during the summer it burns up to a crisp. Do you have a backup place to go to, or do you plan for the kind of dynamic nature of restoration over decades?
Well, so we haven't done the same work that you've done in terms of the temporal aspect of modeling out over years. But how we're using it so far is to set the context. How much need is there within certain portions of the landscape? And if we think about, we're seeing on the order of 10,000 or 50,000 acres of need within a low severity forest. We would hope to have that treated within a 5 to 10, 15 year time span to meet the sort of natural disturbance return cycle. But that temporal aspect is something that I think is really important, and at this point we haven't directly addressed. We kept it static, so to allow us to scale up and go across millions of acres instead of just thousands, we've sacrificed some of that temporal information. If that makes sense.
Yes.
Yeah, I had a question on the Clearwater. How you accounted for the loss of white pine, and also the general pervasiveness of root disease in those mid-Cyril, Grand Fir, Douglas fir stands?
Yeah, so that's a great question. So, and on this first run through of using the Landfire data, we did not directly account for the loss of white pine, but that is a huge issue in the northern Rockies. We didn't account for it because the Landfire current condition data, we weren't able to pull out species composition. So the next phase of the work that we're doing with the Clearwater Basin Collaborative is to dive in, use these same concepts, but use some of the mapping products that the Forest Service is developing explicitly for the Nez Perce and Clearwater that do a much better job of accounting for species composition. And so in the next round of our work, presence or absence of white pine and opportunities for white pine restoration will be an explicit focus of our restoration needs analysis.
Were you able to model the root diseases in the VDDT?
The root diseases are incorporated into the VDDT models. I worked with some folks, Terry Jane, Penny Morgan, Zach Graham, some other local experts to review some of, especially the white pine models to assess the root disease dynamics. Not perfect, but it is incorporated.
Yeah, great. Thank you.
So this is Randy here with 2 quick points. I'm keen to help you if you want to try and apply Ryan's approach to your landscape. I can provide some of that, energy to some degree, or the Landfire team can, or maybe we can find some way to help you kind of bridge the gap. And also, I would say regarding the Louis' question, I was just thinking that Landfire has what's called an area change tool that you could use, or I'm sure GIS analysts have many ways to do this, but you could take those base maps you've created and throw in the new fire perimeter, and if you could assess what the effects of that fire were at some level that's meaningful, you could change the succession class labels or somehow relabel that area so that you could sort of do some recalculations if you needed to.
Yeah, and Randy, I'd like to hop on that. That is, I forgot to mention earlier, but one of the ideas we're looking at in terms of monitoring is updating our current condition data set. So we can say, year 2010, this is what restoration needs looked like after, 5 years later, after wildfire, after treatments. How has that changed the restoration need across the landscape? Hopefully it's reduced it. Maybe it hasn't. But exactly as Randy said, by incorporating those disturbances into our current condition data layers.